Hello everybody and welcome to this Helix webinar. My name is Mark Walters. I'm a member of the SEAL team here at BMC, and for the last couple of years my primary focus has been the Helix on-prem products. You may have seen some of my other webinars, particularly on the Helix IS releases. Today we're going to be having a look at the use of SSL within Helix, how it's configured, some of the maintenance things that you need to do, updating certificates for example, and some troubleshooting tips. The agenda for today will start off with just a few SSL basics. Hopefully everybody's familiar with the technology, but there's a couple of things we want to call out. We'll look at the Helix architecture and how SSL fits into that. There's a little bit about certificate types, the different certificates that you can use, how SSL is used in Helix in more detail, the different areas, the different types of connection where it's in use, but also where it's not in use. And then we'll finish off with some troubleshooting tips and some Q&A hopefully. So SSL basics. SSL Secure Sockets Layer is a protocol used to encrypt communications between systems. Most people today, I think, will be familiar with the technology, at least should be used to seeing it. Pretty much every website now has moved to using HTTPS, using SSL as its primary communication. It obviously offers the benefit of encrypting the traffic as it travels between the client and the system, the server system that it's talking to. It also provides methods for validating that data, so checksums to make sure the data is not being interfered with, and it also provides a trust mechanism. The certificates that are used at either end of the connection can be used to actually validate and make sure that the system that you're talking to really is the one that it claims to be. Obviously if you're using something for commercial transactions, if you're talking to your bank for example, you want to make sure that it really is that site that you're using and not something or somebody that's pretending to be them. So SSL has a facility on top of the encryption that helps manage and ensure that integrity of the connection. That's the SSL trust model. It uses the concept of a certificate and a chain of trust. So the certificates that websites typically offer up when a connection is established have to be signed by a trusted authority. There are a number of very well-known public CAs, certificate authorities, and most browsers, well in fact all browsers and operating systems will ship with a set of those certificates pre-installed, and they're the highest level of certificate trust. Those certificates are used to sign and generate other certificates. Those can either be directly for use by a system that's offering them up, a web server for example, or they can be used as intermediate certificates. So your highest level certificate authority can issue a certificate which itself can then be used to generate others, and it's that chain of trust that's important. Clients that receive a certificate from a site and want to verify it, they need to have access to all of those certificates that are in that chain to be able to make sure that that they're authentic and that they can be trusted. So this chain of trust, we'll try and sort of demonstrate it here. As I say, most operating systems, most browsers, a lot of applications include a trust store out of the box. So this is a set of default certificates which are known to be trusted. Java programs and non-Java programs use slightly different ways of storing those. On the Java side, we tend to call them key stores. It may be a JKS file. And on the non-Java side, these are more commonly PEM, PEMS or CRT certificates, and there are different tools for working with them. I say the important thing is that when you come as a client, as an end user, when you are offered up a certificate by a server that you're connecting to or a system that you're trying to use, you need to have access to both the root certificate that actually issued the certificate that you're using, but also any intermediates. So for example, a company like BMC, we have a lot of test systems internally that use SSL. We don't want to go to commercial certificate authorities every time we need to get a certificate and buy them. So we've either generated our own certificates using an internal certificate authority, or for some of the systems that we test or we use for testing where we need a more realistic sort of real world approach, we have a certificate that we bought from a commercial CA that we then use itself to generate more certificates. So that becomes an intermediate. So the Helix architecture, where is SSL used and how is it used? You'll no doubt be familiar with this particular slide. If you've seen any of the Helix webinars, this keeps cropping up. So this is the deployment architecture. The Helix on-prem products are deployed in Kubernetes. The ITSM service management components sit in one namespace. The Helix platform components, the common services, RSSO, Elasticsearch and FTS sit in the lower one. There are lots of different places within this architecture that SSL can be used. Some of them are optional, some of them are mandatory. So SSL has to be used or must be used between the external clients and the load balanced host names. So the application URLs that you have for the mid-tier, for RSSO, for DWP and the Helix portal, those types of components. That is always SSL connected. Connections from the pods to external applications. So some of the pods, the Helix IS platform pods, for example, they run a plugin which needs to talk to the RSSO system. And they do that using that external application hostname. So that connection also has to be SSL encrypted, which means that certificates are required. There are some components which are optional. So the connection from the load balancer to the ingress controller. The ingress controller is the component that runs in the cluster that routes the incoming request to the appropriate services. So when you type into your browser the URL for your mid-tier or for your business workflows, that request typically gets sent to a load balancer. The load balancer forwards it on to an ingress controller, and then the ingress controller matches that URL against a set of rules that it has and sends that off to the appropriate services and pods. So the connection between the client and the load balancer has to be encrypted. The load balancer may do the decrypting, or it may pass through that SSL connection and allow the ingress controller to do it. And that's what we call either SSL offloading or pass-through, and we'll see a little bit more of that later on. The Kubernetes connections to the local registry server. So your application components, pods that are running in the cluster, they are built for using a container image, and that container image comes from a registry server. Typically, that registry server offers its connections using SSL. It's not required. You can configure in secure registries, but the default is secure. So you'll need to configure certificates in your cluster to be able to access your registry server. Applications and running to third-party services. So some of the components within Helix, let's take, for example, let's say you have an integration and you have an application running in your as part of your Helix system that needs to access an external REST API, or maybe an external mail server that uses SMTPS, uses an encrypted connection. You need to provide certificates to those application pods so that they can work with those external services. And you may also choose to enable SSL on the Jenkins web interface that's used for the Helix IS deployment. Some secure customers I know need to do that. It's typically not encrypted, not enabled, but it is an option if you want to do it. There are a couple of places where it's not used. So connections from the ingress controller to the application pods themselves. So remember, the incoming requests come into the load balancer sends them to the ingress controller. By the time they've got to the ingress controller, by the time they leave the ingress controller, they are decrypted. So the actual applications themselves generally don't run SSL enabled. The encryption is handled external to that, either by the load balancer or by the ingress controller. And so the traffic that passes from the ingress controller pods onto the applications is unencrypted. It's also not used generally for connections between application pods. So RSSO, for example, talks to Postgres. There are lots of other components particularly in the Helix platform, that interact, and they generally don't use SSL connections because of the overhead of managing the certificates and the load from actually handling the encryption. There are a couple of examples which are of a particular note on the IS side. One of those is for if you're sending data to Helix logging, that uses an encrypted connection, and also the FTS Elasticsearch, the Elasticsearch system in the Helix platform that's used for FTS on the IS side, that connection is encrypted. And that's actually something we'll see later in the troubleshooting, is an area that a number of customers have run into issues. And the certificates that are needed to deal with that are included in the installation out of the box. So what are the different types of certificates that we actually need? There are three main ones really that you need to be aware of, or three main types as far as Helix is concerned. The first of those offered or issued by commercial certificate authorities. So DigiCert, Entrust, there are many of them. A quick Google, a quick search will throw up dozens, if not hundreds, of different certificate providers. DigiCert is a special case. For some reason, the DigiCert root certificates have been included in all of the Helix pods. So any certificate that's issued by DigiCert is automatically trusted, and there's no further application configuration required, no further special steps needed within Helix to make that work, other than actually configuring the certificate in the load balancer or ingress controller in the first place. That only applies to DigiCert. For all other commercial CAs, we need to use the same process as we do for custom CAs, which involves actually configuring and preparing those certificates in such a way that the installation has access to them and can configure them in the cluster for use by the pods. Custom CAs, so these could be certificate authorities that you have set up internally. So you can generate your own certificates from scratch. There are a number of tools and sites on the web that will help you do that. Typically you use something like the OpenSSL commands to generate a set of keys and certificates, and then you can use those to issue further certificates, either direct for use by a server or as intermediates for use to issue certificates further down the line. Custom CAs, the process that we use within Helix to provide certificates to the applications, we use the same process regardless of whether they're entirely internal or whether they're intermediate certificates that were issued by a commercial certificate authority. As far as the applications are concerned, it's the same thing. It's a chain of certificates, and you need to make sure that both the root and any intermediates are included in the configuration that are used when setting up the applications. And then finally, you can choose to use entirely self-signed certificates. So this is it's useful possibly for test environments. You generate a single certificate which has all of the URLs within it, and then you explicitly tell the applications that they should trust that certificate. It has an advantage that it's quick and relatively easy to do for a test system. The big disadvantage is that self-signed certificate that you've generated has to then be provided and configured on every client that wants to use your system. That might be fine for a test environment with only one or two users, but you can see as that starts to scale, the overhead of managing that self-signed certificate becomes a bit of a nuisance. There are two ways of configuring the application host names, URLs, aliases, whatever you want to call them, that are required for Helix within a certificate. The quick and easy way is to use a wildcard. So you can set up your Kubernetes cluster with a particular domain name, and you can generate a wildcard certificate so that any host with that domain name is trusted. Again, probably more useful for test environments. A lot of companies, a lot of enterprises won't allow this for security reasons. Obviously, there's potential there if miscreants get access to the keys to generate the certificates, or are able to manipulate the certificates, they can make them look like anything within that domain. Again, so it might be useful for a test environment. You probably won't come across that or won't use that for production systems, in which case you'll use the second option, which is a SAN, a subject alternate name. So when you actually come to request the certificate, it means that you need to explicitly list all of the host names, all of the application URLs that you want the certificate to be valid for. The disadvantage of this method is, of course, if a new alias needs to be added, you need to generate a new certificate. So that there is a bit of extra overhead of managing that if you choose to go that route. How do you actually get a certificate? First of all, you start off by preparing what's called a CSR, or a certificate signing request, and there you need to provide information about who you are. Some of this is optional, depending, and it will depend on the CA, the certificate authority that you're using, exactly what information they require. If you're using an internal CA for testing, the requirements will probably be much less stringent. So you need to provide your details, and of course the host name or names, if it's not a wildcard, that you want the certificate to be valid for. The CSR gets sent off to your certificate issuer, either the commercial one or an internal one, possibly if you're a large enough company. That CSR may request some validation. Commercial CAs, it varies by provider. Some of them ask that you set up a DNS entry that allows them to prove that you own you own the URLs or host names that you're requesting the certificate for. Others may require confirmation via a company email address or PO or whatever. So it will vary depending on the provider, and they will let you know what they need. Once the certificate is generated, you'll receive that and its keys back from the CA. And then, depending on how and where you're going to use them, each application has different methods for setting these up. You'll need to configure them in your web server, your ingress controller, your load balancer. You add those certificates in so that clients can start using them. So how and where is SSL used and configured in Helix? So as I was sort of trying to explain earlier, this is a graphical representation, or an attempt at a graphical representation to show how traffic gets into these Helix applications. So you start off with a client. The client resolves the DNS alias, which usually resolves to a load balancer. You make a connection to the load balancer. The load balancer forwards those requests onto an Nginx controller pod that's running within your cluster. If you've deployed as per the BMC recommendations, you'll have a daemon set and one ingress controller per worker node, and then that ingress controller will forward those on to the appropriate application. So as I said, you have a choice of where that SSL certificate that you're using for Helix is configured. If you configure it at the load balancer, then that offloads some of the overhead of the CPU usage of actually decrypting and decoding those connections to dedicated hardware. Many load balancers have specific chips and functionality to help them do that quickly. How you do that and how you set that out will be specific to your load balancer, whether it's F5 or maybe it's a software-based one, HA proxy, for example. They'll have different steps, so have a look at the documentation to help you figure out how to do that. If you decide to do it at the ingress controller, so the encrypted connection comes into the load balancer just passes it through, and it's up to the ingress controller to do the decoding. In this case, you need to create a secret using the certificate and the keys that were provided by your certificate authority. That's created within a namespace in the cluster, and then you change the configuration of Ingress Nginx. There's a particular certificate configuration item that you need to add to the controller config there to tell it which certificate to use. It is possible to it's technically possible to configure each ingress to use a different certificate. That's not a method that's used with Helix at the moment, which is why we rely on the default SSL certificate. This is, I say, another attempt to try and sort of demonstrate how this, to show how this works. The connection in green is showing the SSL offloading route. So the client passes an HTTPS request to the load balancer. The load balancer has those certificates configured. It can do the decoding, and then the request that it passes on to the ingress controllers is in a decoded form. It's HTTP, and then they route it onto the applications. If you're terminating SSL at the ingress controller, it's the red route. So HTTPS SSL from the client to the load balancer. The load balancer simply passes it through to the ingress controllers. They decode it and then pass the requests onto the relevant application pods. Configuring SSL within both the Helix platform and IS, two different processes. Obviously, we have the shell script, the deployment manager script for the Helix platform, and we use Jenkins for the Helix IS for the service management components. For the Helix platform, you add your certificates to a custom CA cert.pem file. So this is a text file that has one or more certificates included in it. So if you're using a certificate that's been issued by a CA or that has an intermediate, you will have several certificates potentially in this custom CA cert.pem. When you then run the deployment manager script, it has code within it that reads those different certificates and then converts them into different formats for use by the applications. It's important to note that the order that those certificates are put in that PEM file matter. So you go from the most specific to the least specific. So if you're including the actual certificate itself, it's an interesting point. This needs a little bit of clarification, I think. For Helix IS use only, you don't need to include the actual application URL certificate in the PEM file. You can just use any intermediates if you have them and the root certificate. I think there might be use cases on the ITOM side, perhaps to do with BHOM and the patrol agents, where the actual the certificate itself, the same one that you configure on the load balancer or the ingress controller, that's also needed in the custom CA certs. I think there might be something in the documentation about it, but at this point, what's important here is it's the order that's significant. You need to make sure you have them in the right order, and we'll see a little bit later on there's a tool that you can use to help validate that. You copy the file to a particular location, set a couple of options or one or more options in the infra config to tell the application installer that you're using a custom cert, and then run the script, and it should do the job. Part of the pre-checks that are run by the deployment manager script will also attempt to validate the certificates. So if you've missed one or misconfigured them, it should hopefully check and catch it at that point. On the Helix IS side, say we use Jenkins, a different process, the GUI-based installer, and this uses a Java key store. So rather than the text file with the certificates that you can just cut and paste into, you need to download a Java CA certs key store file from BMC. You then need to use the Java key tool command to add each of your certificates. If you have multiple certificates, the intermediates and the root possibly into that CA certs file, and then every time that you run the Helix on-prem deployment manager, the Helix on-prem deployment pipeline within Jenkins, you need to remember to attach the CA certs file. So that's during, if you need to rerun during installation, maybe because you've encountered an error, you fixed the error and you're rerunning the pipeline, you'll need to reattach it. Or if you're using it in service mode at a later date, maybe to change things like the DB credentials, for example, where you need to update the cluster. If you forget to do it, if you forget to attach that CA certs file, the config map, the secret that's in the Helix IS namespace where that's stored will be overwritten with the default out-of-the-box CA certs file, which doesn't include your certificates. And at that point, you'll start to get authentication issues from the IS applications because they are no longer able to talk to our SSO. They need they need your custom certs to be able to talk to our SSO for validation and logging in. So you will start to see errors. There is a way to avoid, or to try and avoid that. You can actually commit or check in your CA certs file to the repo, to the Git repositories that Jenkins uses. So that's the tips at the bottom of the screen there, the steps to actually take your updated CA certs file, the one that you downloaded from BMC and that you've added your own certificates to, and you can replace the out-of-the-box one that's in those Git repositories with that. So then it doesn't matter whether you remember to attach the CA certs file or not, because it's always the one that's in the repositories is the correct one. If you have integrations or applications running within your system that need to access external third-party sites that use encryption, there are going to be different types. There are going to be different methods for adding those certificates depending on what exactly the use case is. For the Helix platform side, it's generally just you need to add it to the custom CA cert.pem. So ideally you would know this before you start deployment. So any certificates that you need, you can add in and they're there from day one. However, if you find further down the line that you need to add new certificates, the documentation includes some steps. It's the same steps that are used for updating the certificates in the event that, for example, they've expired. So you need to refresh them. So you can add those in. So for the platform, it would be included in the custom CA cert.pem. The exception at the bottom of the screen there is for our SSO. If you're using SAML authentication or a SAML integration with our SSO, there's a separate process, there's a separate file used for passing the certificate for that into our SSO. But for everything else, it goes into the custom CA cert.pem. And for the Helix IS side, so for example, if you're using the REST API plugin that's part of the Innovation Suite server, that goes into the CA certs file. So you add that to the CA certs key store. That CA certs file is mounted into the various pods that have that functionality or that require that functionality, and those certificates are then available. So that would be, for example, for maybe you're using an LDAP server, using ARDBC LDAP, and that LDAP server is SSL enabled. You put your certificate into the CA cert file and it's automatically exposed and made available to the applications. So the interesting bit, hopefully, also, how do you, what's likely to go wrong? How do you identify what's gone wrong, and what can you do to fix it? The first place to start, and I've stumbled across this website and I found it incredibly useful, is that it's a certificate checker. So before you even start deployment, once you've got your certificates from your CA, take the certificates, so these are the same certificates that you would use in your custom CA cert.pem, paste them into this website and click the button to validate them. And what this will do is it will make sure that the certificates that you have are a complete chain. So for example, if you were missing either the intermediate or the root CA, if it wasn't one of the publicly well-known ones, you'd get an error. So this tells you straight away that you've got a problem and that you're missing a certificate that you need to add to that PEM file. The other thing it will throw up is if the certificates are in the wrong order. So if you've got them the wrong way around, maybe you've got the root and the intermediate the wrong way around, it will highlight that. If all of the required certificates are there, then you get a nice confirmation message, and you know you should be okay to use that within your deployment. The other useful tool that it's got is the certificate chain composer. So if, for example, you are using let's say your organization has bought a certificate from a commercial CA and they're using that as an intermediate to generate further certificates, you're going to have a chain there. If you're missing the root CA, which is easy enough to do if maybe the certificate authority has only provided you with the certificate and the intermediate, perhaps because they assume you've got the root. This will highlight that, but also it has the option, if it's a well-known public CA, it'll go and fetch that certificate and append it to the file. So you can click on the compose button, have the chain completed, and then that gives you the full contents that you would need to use in the PEM file. So a very handy little tool. There are some things that you can do from the command line. So on the deployment engine, for example, before you start your deployment, you can use the OpenSSL command. That can be used to display the contents of the PEM file. So you can see the certificates in a decrypted, decoded form and see their contents. That might be useful, for example, to make sure that all of the SANs, all of the relevant host names, aliases that you need for Helix are included. Once you've got your certificate installed in the ingress controller or the load balancer, you can use tools like, again, OpenSSL or curl to actually talk to that endpoint. And the nice thing is that you can tell the client, curl and OpenSSL, to use that custom ca-cert.pem as a certificate store, and that allows you to validate that ca-cert PEM file that's contains all of the required certificates. If one of them's missing, you'll get an error. So you can tell straight away that you've got the right thing. We can do the same thing for the Java key stores, the ca-certs file, using a tool called SSL poke. So that's freely available, easily found on the web. It's a little bit of Java code you can download and compile. And then you can also, if you do run into problems with the Java-based ones, there's a very useful command line flag, this JavaX net debug, that will produce lots of additional information, and it's useful for help, for example, to help identifying missing certificates. SSL issues will often show up, not always, but often show up with maybe a pod not being able to become ready, and that's because the application that's running within it is unable to complete a connection to another system because it's missing a certificate. So one of the things that it's always worth doing during a deployment is to keep an eye, to keep monitoring the status of the pods within the namespace that you're deploying into. So use, for example, here kubectl get pods for your Helix IS namespace, and we can see that the platform FTS pod, it's running, so the image is there and the container's being created, the pod's being created, but the application itself has not ever become ready, and it's been running for over an hour. So clearly there's something wrong. If the pod was in, for example, a pending status, that's likely to be a resource issue. The image pull back off status is another one that you might see, is if you're missing credentials for your registry server. So again, that might be a certificate issue, but that will have shown up pretty much as soon as you started. So it's more likely to be maybe a change of credentials. And then finally, once the pod is ready, if the pod shows running but never becomes ready, so the ready remains less than the column, the numbers under the ready column are the number of containers on the right hand side and the number of those containers that are ready. Some of the Helix pods are made up of multiple containers. The platform FTS one is a good example. If you don't choose to install the support assistant tool and the Fluent Bit, or enable the Fluent Bit integration, you'll only have one container in the pod. You may have two, or either two or three if those other two options are selected. In this case, we've only got the one, but it's not ready. So 0 out of 1 containers within the pod are ready. So then you can use things like kubectl logs to have a look at the output, the standard output of the application that's running in the container. And that might give you some clues as to what's going wrong. So if the application is a Java application, for example, these are the types of errors that you will see that are related to SSL. So the top one, the unable to find valid certification path, that's a that's a giveaway that you're missing a certificate. So chances are you're missing either the intermediate or the root because it's a custom CA that's part of your CA certs file. Or this is the error that will occur if you've accidentally run the Jenkins pipeline without attaching the CA certs file, and it's defaulted to the out of the box one. So your custom CA certs has disappeared. If you misconfigure the port number, so maybe you're going to a non-SSL port, you'll see the second one. It hints plain text connection. So that's a possibility if you're connecting to a service that has multiple ports, not all of which are SSL enabled. If you get the host name wrong, I've seen this a few times. For example, something as simple as a typo there in platform where you're missing a letter, you'll get a service or name not known error. Credentials error, so a mistake in a username or password, show up as HTTP 401 unauthorized, and then again the wrong port number. If the application is there, but you're connecting on a port number that's invalid rather than one that's non-SSL, you'll typically see something like a timeout. So the particular error, once you can find it, should hopefully be helpful in diagnosing what the underlying root cause is. There are a couple of specific issues that you may see that are related to the Helix IS platform pods and FTS. So as I mentioned earlier, the Elasticsearch service that is used for FTS that runs in the Helix platform namespace is unusual in the sense that it uses SSL internally. So it uses SSL SSL is required for connections from other pods running within the system to talk to that Elasticsearch server, and that uses a self-signed certificate that is configured automatically and is included in the deployment. It's part of that CA certs file that you download from BMC, and it's included in the out-of-the-box one. However, there have been a number of occasions where, for one reason or another, a customer has accidentally maybe they've created a new CA certs file that only has their certificates in, rather than adding them to the BMC provided one. In that case, the certificate that's needed for connection to Elasticsearch is missing. So that's typically will show up. That's the that will show up as the unable to the failed to find the path to the certificate. The first example on the previous slide is the type of error you will see there because it's missing the certificate that it needs. The other things that you can check, there are a number of Elasticsearch variables that need to be set in the pod. These are all inherited from the on-prem deployment pipeline. Typical mistakes here are having the secure option set to false or using the wrong password. This is hard-coded as admin and can't be changed at the moment. Some customers have misunderstood the pipeline and think that this is an example of one of those where you're defining a password. It's not. You need to provide one. And again, as I said, an example on the previous slide, if there's a typo or you get the wrong Elasticsearch hostname service, and that's also worth noting. That varies depending on the version of the Helix platform that you're using. The example on the screen is for 23.4 and upwards, I think, where we switched to using OpenSearch instead of OpenDistro or Elasticsearch as the provider. So you need to make sure you've got the right service name for the version of the Helix platform that you're using. If you can get a command prompt in the pod, you can use a curl command there to actually validate the connection. So you should be able to make sure that that's all up and running, because it's always possible that there's an issue with Elasticsearch itself. So you might find that although you've got a valid connection and all your settings are correct, if Elasticsearch isn't running, you'll see a problem there. And that's what the bottom one there is, how to validate the problem that if you've accidentally lost or deleted the ES node certificate. So you can list the certificates that are included in the key store, and this also applies for your own. If you want to validate that the certificates that you've added are there, when you added them you would have given them a name, an alias name. You can use that keytool command to validate that they're present. If you are missing a certificate, or there's a certificate error, it typically shows up when you try and log in, for example, to the mid-tier as either a 623 error or a 0 error. So there's a few steps that you can take to help to troubleshoot which one of those it might be and help you understand what steps you need to fix that. First of all, try the different applications. Is it across all of them or just some of them? If it's only one of them, you're probably more likely to have to look at the application configuration for that specific pod. If it's all of them, it's more likely to be an issue maybe at the platform or at a wider system level, because it's more general. Try logging in as different users. If you're able to log in if the problem is only for one user, it's much more likely that it's an issue with their password rather than a system issue. If everybody gets the same error, you've probably got a misconfiguration. You can use a command prompt in the platform pod. It's a very handy place to go and look for these type of issues, because the RSSO plugin that's run in there will contain, or has to use the certificates to be able to work. So that's a good place to look to diagnose and troubleshoot certificate issues. Have a look in the Java plugin log for the authentication plugin. Look in the RSSO log that's listed there. If you've got problems with the on the RSSO realm, for example, where you've configured the application URLs there and the tenant name, they will show. If you've misconfigured one of those, it will show up there. Check those values in those two configuration files and make sure that they're consistent with the other components. Use SSL poke if you can. The platform pod includes the Java compiler, at least the current versions do, so you should be able to download and run SSL poke in there to validate that the CA certs file that's in the pod has the certificates. Or again, you can use the keytool command to list and have a look. You can't use things like curl and OpenSSL in the platform pods because we don't have the PEM version of the certificate in there. It's only the Java CA certs file that's available. We're moving towards, or BMC are moving towards, minimizing the extra binaries and the size of the containers, the pods that we provide. So many of these little tools like curl and OpenSSL might be disappearing, or either already have or will in the future. So there's a couple of steps that you can take to actually extract the certificates that are in use from the system, so that you can do a little bit more digging onto them, or digging into them. So if you want to get them from your load balancer, you can use OpenSSL there to save them out to a file. You can get them from the Helix platform namespace, where they're saved as config maps, again, and save them. Both as the Java key store and the text version. On the IS side, it's a secret, so you can extract it there. And then the last step there shouldn't often be necessary, but the contents of the Java key store are not usable by some other commands like curl and OpenSSL, for example. They're in the wrong format. So there are some steps there that you can use to convert them if need be. So that will give you a local version of those certificates that you can dig into using various tools. The maintenance side, sooner or later you'll need to update your certificates, either because they've expired or maybe because you need to add a new host name if you're using SANS. If the certificates that you've added to the system are only the intermediates and root, and the new certificates are generated by the same CA, you shouldn't have to modify the deployed applications. It should be enough to simply update the certificate in the load balancer or ingress controller, because the components that have used to sign and generate that certificate are the same ones. So depending on exactly what you installed, you may not have to update if you're adding a new host name, you may not have to update the components that are in the cluster. If the certificate's expired, depending on which one it is, if the intermediate certificate has expired, for example, then you will. And there are different steps to do that for both the Helix platform and Helix IS. The platform is slightly more there are more steps involved, because you have to update this config, you have to use this custom CA cert, and you have to add, you have to update both the CA certs file and a PEM file, a config map. So there are steps there that are actually in the documentation that we won't go into in detail. On the IS side, you add the new certificates to the CA certs file, and you can either run the Helix on-prem deployment pipeline in service mode. The reason I say caution there is more than one customer has run into issues rerunning the pipeline because they accidentally change one of the other values, one of the other parameters that's in the pipeline. So an easier way to do that is you can actually, once you've created the new CA certs file with the certificates, once it's been updated, you can delete and recreate the secret in the namespace. And that's then job done. Some of the pods you may need to restart for them to pick up the new file, but you don't have to use Jenkins to update it. The one important thing to point out in that case is that the file name that you use to create the secret must be CA certs, because that gets encoded into the secret, and that's needed by the applications. That's what they're looking for. So don't call your CA certs file new CA certs or updated CA certs, for example. It must be called CA certs if you use that method. Selection of references here. These will be included obviously as part of the when we put this information on the Connect with on the BMC website, on the community's website that links to this presentation and the recording, so that you can click on them. But there are documentation links there for the IS, for the service management components, the different parts of the documentation that talk about configuring and using the certificates. The same for the Helix platform, and then there at the bottom some useful links that I've found that are being referenced throughout this session on using debugging and troubleshooting the different components. It might help you understand if you need to dig a little bit deeper. I thank you very much for your time, and hopefully now we have time for some Q&A.